All right, we're going to continue our naming review with the last and final piece of Chapter 2 and the last and final piece of what you named last year, a little bit of organic chemistry. So what you see on the board might be a little review from the last year in May. All we did were simple organic compounds like the three you have on the board here: methane, ethane, and propane. Now you may remember that you might see like propane might be drawn like that because in between each, on the end of each line, is a carbon, if you can remember that. Remember, there are three different types of organic bonds. You have alkanes, alkenes, and alkynes. Alkanes are single bonds, alkenes are double bonds, and alkynes are triple bonds. The prefixes we use vary slightly from what we are using when we are comparing two nonmetals, and it really only changes for the first four. So meth is 1, as you can note here, eth is 2, prop is 3, and but is 4. After 4, 5 through 10 are the same as naming nonmetals: penta, hexa, hepta, octa, non, and dec are your prefixes for naming organic molecules. So they are the simplest hydrocarbons. They contain only hydrogen and only carbon. We talked about kind of how we name them. Now, the one interesting thing, and the one thing that we did not talk about last year, and we will go more in depth later in the year, is you can add a functional group to a organic compound. And what is a functional group? Essentially, prior here, I had methane. I had an H. Well, what happens is if I remove this H out of the equation, I can add a functional group. And the functional group is going to change the properties of the entire organic molecule. In this case, we added an alcohol group, and alcohol is OH. So alcohols are OH. And what happens to alcohols, and we will do naming later in the year, I simply want to expose you to the different types of side groups that you can have instead of just H's. So OH is one group, and it is called an alcohol. If we go to, I have to add a slide here. If we go to the other slide, what we can do is we can talk about the different variety of side groups that we have here. Apologize for the delay. As let me insert another page here. All right, what we're going to have here is let's talk about the different types of side groups that we had. We talked about alcohols as OH. And all I'm going to do is I'm going to kind of label the side group and what it is. So alcohols are OH. There are quite a few of side groups, and kind of they change the properties a little bit. So what we have here is, I'm going to pretend we have a C, and if that C bonds to an OH, that's an alcohol. But if we remove it with another H and it double bonds with an oxygen, that is called a carboxylic acid. And these are weak acids. And really, don't worry about memorizing these right away. I just want you kind of to get some exposure to the different types of side groups that there are. Now, if we just remove one and we have a double bond, and we continue with the rest of our chain here, this is an aldehyde. Now, you may remember something like formaldehyde, right? Well, formaldehyde is kind of a branch, is going to be a type of aldehyde that we can have. You can, let's see here, what else do I want to expose you to? If we have, again, a double bond with R, but instead we have a branch of more carbons and a branch of more carbons, instead of being called an aldehyde, that is called a ketone. And the last one I kind of want to expose you to is amines. So like methamphetamines, amines are the group that looks something like this. You have an N, and then it is bonded to whatever it's bonded to. A C, and then the N can be bonded to whatever, and that is an amine. I really simply just want to expose you to the different types of organic molecules. There are a couple others that when we talk about this towards the end of the year, right before the AP test, this is one of the last chapters that we do, we will discuss kind of how this works and how you name ketones and how they work, but in all these other side branches. But for now, just kind of get a general idea of what they may look like in case we see them throughout the course of the year.